Next is hypothesis testing. I have two tabs for hypothesis testing. Open HT, and this includes all the formulas and procedure. And the next tab is where we'll do the computation. We'll look at an example, numerical example. Now, hypothesis testing involves first setting up the hypothesis and then testing the hypothesis. When you set up the hypothesis, you need to remember that there are three ways in which it can be set up. One in which the null hypothesis is mu equal to some value that we are interested in, against the alternative mu not equal to that value. And when you have not equal to as the alternative, that is called a two-tailed test. Now the second form is when mu is less than or equal to some value as the null hypothesis, and the alternative is the opposite of that, will be mu greater than, and since the opposite of that, mu greater than that value. This is a one-tailed test because the alternative is mu greater than. And similarly, the third form is when the null hypothesis is mu greater than or equal to some given value against the alternative mu less than that value. And once again, since this is less than, it is once again, this alternative is less than, and therefore that is also a one-tailed test. Now, the population condition could be that the null hypothesis is true or null hypothesis is false under any of these three different hypotheses. But we are going to make a conclusion based on the sample, and we may conclude that HO is true or HO is false. Now, if our conclusion matches with the underlying population condition, then the decision is correct, okay, in these two cases. But if not, for instance, if the underlying population condition is that HO is true, but based on the sample we conclude that it is false, then we will be committing what is called type 1 error. And the probability of type 1 error is the p-value, and the probability of type 2 error is called beta error. We will be making a conclusion about the hypothesis based on the type 1 error. So we will set a maximum value for type 1 error, which is called alpha, and also called level of significance. So if the probability of type 1 error, if p-value is less than or equal to the level of significance, then we can safely conclude that HO is false, or in other words, we can reject null hypothesis. So that is going to be the basis upon which we will conduct the test. So after setting up the hypothesis, in step 1, we will calculate the type 1 error for the hypothesis, and if that type 1 error probability is less than or equal to alpha, then we will reject the null hypothesis. Otherwise, we cannot reject. Now, how do we compute the p-value? To compute p-value, we first need to compute the t-statistic. T-statistic is given by this formula. Once we have computed the t-statistic, then using the t-statistics, we can calculate the p-value using one of these two functions. If it is a two-tailed test, we will use t.dist.2t, or if it is a one-tailed test, we will use t.dist.rt. In either of these two cases, we will use the absolute value of the t that we calculate, and then of course we need to provide the degrees of freedom for either of these two functions. The degrees of freedom is given by n minus 1. And we'll look at numerical example in the next tab.